Hi students, this is going to be the fourth video lecture for the subject EC304 VLSI. In this lecture we will learn part 2 of module 5 dealing with RAM. Again moving on to the syllabus of fifth module. Fifth module is dealing with different types of memories as the first part, and the second part is the sense amplifiers. So we are dealing with the first part, and we have already covered the first category or first part, that is the RAM cell, the first type of RAM cell, that is SRAM, and we have learned the configuration of SRAM 60 transistor or 66 transistor CMOS RAM cell structure and its read and write operation. Today we will learn about DRAM, that is dynamic RAM, and we will learn about the 3 transistor and 1 transistor configuration of DRAM. So today we will learn about the second type of RAM, that is dynamic RAM, and its 2 configurations. So the main difference between SRAM and DRAM is in the method of data storage. In SRAM, the data is stored based on feedback storage method, where we have 2 cross-coupled inverters are placed and the data is stored in that cross-coupled configuration. Whereas in dynamic RAM, the data will be stored in a capacitor. So capacitive storage is the speciality of dynamic RAM. Moving on to the first configuration, or first we can learn about the features of dynamic RAM. What is RAM actually? RAM is random access memory, so we can read or write anything onto these memory structures. So DRAM is making use of capacitive storage. So fully charged capacitor means it is storing a value 1, and fully discharged capacitor means it is storing a value 0. As capacitive storage is used, capacitive leakage issues will be there. So to compensate for capacitive leakage issues, DRAM has to be refreshed periodically every 1 to 4 millisecond, every 4 to 1 millisecond time periods. Okay. Refresh means what? Reading the data content of the cell, and writing the same content to the cell. That is actually the refresh operation means. So we need to do this refresh operation every 1 to 4 millisecond time. Moving on to the 2 configurations, we have 2 configurations for the dynamic RAM, that is 3 transistor configuration and 1 transistor configuration. First we will learn about 3. So you can see here. So for the read operation, which bit line has to be used? BL2 has to be used. Why? Because the read word line, that is the word line that will be enabled during the read operation, is actually connected to the transistor M3, and that transistor M3 has got connection with BL2. So during read operation we have to concentrate on the BL2 line. So the first step in the read operation is pre-charge BL2 to VDD. That is the first step. Okay. So as okay. Now the second step is enable the respective word line. So here we are doing the read operation. So the word line RWL will be enabled. So as we enable RWL, the transistor M3 will get turned on. Okay. After that, what about this transistor M2? For this case, M1 will be off. Okay, because WWL will not be enabled, so M1 will be off. What about the case of M2? Actually, the status of M2 depends on the voltage at X, or the storage value in the capacitor CS. Okay, if the stored value is 1, that is the voltage at X will be VDD, then the transistor M2 will be on. Okay, if the stored value is 0, then the voltage at X will be 0, then M2 will be off. So what we are doing here, we are doing the reading operation. Suppose the value here is 1, what happens? M2 will be on. So M3 is already on because we have enabled the RWL line, and we have pre-charged BL2 to VDD. So this VDD will be discharged, will be shorted. will get a path to the ground. This VDD will get a path to the ground through M3 and M2, and the value of BL2 goes to 0. So as if 1 is the value here, then the value of the charge, this BL2 line will drop from VDD to 0. Okay, if the stored value is 0, then what happens? M2 will be off, so only M3 is turned on. So what happens? The pre-charged value of BL2 will retain as VDD itself. So as a conclusion, after enabling RWL word line, if BL2 value remains the same as the pre-charged value, that is VDD, then the meaning is that the stored value, the read value, is 0. And if the BL2 value go from the pre-charged value VDD to 0, then that means the stored value is 1. Okay, so that is the read operation of 3T DRAM. So first step is, once again, the read operation, first step is pre-charge BL2 to VDD. Why we have chosen BL2? Because the RWL word line is connected to the transistor M3, which is in have a connection with BL2 actually. Okay, so we need to concentrate in the bit line 2 during the read operation of DRAM. Now second step is enable the respective word line, that is here we are doing the read operation, so we enable the RWL line. So by enabling RWL line, the transistor M3 get turned on and M1 will be off naturally. Now the status of M2 depends on the voltage at X. If the stored value is 1, then the voltage at X will be VDD minus VTH, that is a small drop due to the threshold, due to the that I have already explained. This VTH is actually the voltage drop across the on transistor. Okay, so the maximum voltage to which the capacitor will get stored will be VDD minus VTH. So as if the stored value is 1, then the voltage at X point will be VDD minus VTH. So as a result, M2 will get turned on, and what happens? As M2 get turns on, BL2 line will be connected to ground. So what happens? The pre-charged value VDD will move to 0. And if the stored value is 0, then M2 will be turned off. Then BL2 will retain its pre-charged value. So the conclusion, if BL2 equal to VDD, then stored value is 0. If BL2 equals 0, then stored value will be read as 1. Okay. So I hope you got a clear-cut idea regarding the 3T dynamic RAM cell structure, its read and write operation. So with that idea, we can move on to the second configuration of dynamic RAM, that is the structure of 1T DRAM. This is the structure of 1T DRAM. So during the read operation, what is the first step? Pre-charge BL to VDD by 2. So next step, enable the word line. So as we enable the word line, this transistor has got turned on. Okay. Now, as this transistor gets turned on, suppose if the capacitor value was 1. Okay. So what is the voltage here? VDD minus VTH, or approximately equal to VDD. So the voltage at this point is more than the voltage at this point. What happens then? The voltage at this point starts to share to this area. Here, okay, so the voltage at this point starts to share to this point. So as a result, the voltage at this point starts to increase from VDD by 2 to a little more. Okay, or we can say a positive voltage change can be seen in the bit line. Now consider the second case. Suppose here we have a storage value 0 and we have pre-charged BL to VDD by 2. Then what happens? As we enable word line, M1 will get turned on, and as a result, the voltage for this case, this voltage at this point will be more than the voltage at this point. So as a result, the voltage at this point will get shared to this point. So as a result, what happens? The voltage in the BL will drop. So the conclusion is, if the storage value is 1, then the BL voltage variation will be positive, and if the stored value is 0, then the BL voltage variation will be negative. So depending upon the polarity of voltage variation in the bit line, the user or the read value will be either 1 or read operation. So once again, pre-charge, first step during the read operation of 1T DRAM is pre-charge bit line to VDD by 2, enable the word line. So as we enable the word line, the transistor M1 gets turned on, and as M1 gets turned on, the capacitor and bit lines will get connected, and as it gets connected, the charge distribution takes place. Okay, this results in voltage change in bit line. If a positive voltage change exists in the bit line, then that means the stored value is 1, and if a negative voltage change exists, then that means the stored value is 0. Now what about the features of 1T DRAM? Actually 1T DRAM is destructive in nature because the charge stored in the cell get disturbed during the read operation. You can see because due to this charge sharing operation during the read operation, we can see if a 1 is present, then that voltage across the capacitor will be shared to the bit line. So as a result, what happens, the voltage in the capacitor gets reduces. So after a successful read operation, the original value must be restored. If a logic 0 is present in the capacitor, what happens? Some voltage will be added to the capacitor. So actually the capacitor voltage is varied during the read operation. So after a successful read operation, the original value must be restored. So that's why 1T DRAM is said to be destructive, whereas 3T DRAM is non-destructive, where the stored value is not at all varied there. Okay. And commonly one case for dynamic RAM is that even though naturally normally since it is a capacitive storage, capacitive leakage will be there. Even if the transistor connected to it is in the off condition or so, there exists some leakage current, so its data has got a chance to lose after a prolonged time. So we need to refresh the data inside the capacitor in a periodic time of 1 to 4 milliseconds. After every 1 to 4 millisecond time, the data has to be read and rewrite into the cell. Okay, that is a feature of a dynamic RAM. Now these are certain plots related to 1T DRAM. So this is actually the VW. During the read operation, the voltage at the bit line will be VDD by 2. So if the data to be read is 1, then what happens? This the bit line voltage will get raised. You can see the bit line voltage, because the voltage from the capacitor will get shared to the bit line. So as a result, the voltage in the bit line will be raised. So this is the word line. As word line enable, you can see the voltage in the bit line starts to raise, and this is the point at which the sense amplifier will be enabled. Actually the sense amplifier is finally taking the signal from the bit line to the user. Okay, and we will learn about the sense amplifier as the last part of this module. Now in case 0 was stored, in case 0 is returned to the capacitor, then what happens? As we enable the word line, and the voltage value of the bit line starts to reduce, because the voltage in the bit line now shares to the capacitor. Okay, so that is this plot. Now regarding this plot, this shows the read and write cycle of 1T DRAM. So you can see so this shows the write cycle. So the voltage value at X, or stored value in the capacitor, is 0. So as we write, suppose we are going to write 1, then the capacitor voltage will increase to VDD minus VTN. So during the write operation, the bit line will be what? VDD. During this, because we are going to write 1, so the bit line value will be VDD. Now during the read operation, you can see here what is the value stored in the capacitor. It is actually VDD minus VTN, or high value is actually returned. So during read operation, we need to precharge the BL line to VDD by 2. You can see here, as the word line is enabled, the capacitor voltage starts to decrease. Okay, starts to decrease, and the BL value starts to increase from VDD by 2. So after the read operation, you can see the capacitor voltage now reduces to a new value. That is not actually VDD minus VTN, it is a voltage which is below this VDD minus VTN. So that's why 1T DRAM is said to be destructive. Its voltage has to be restored after the read operation back to VDD minus VTN to store or to preserve that logic 1 value in the capacitor. So that's regarding these plots. Next comes another small topic, that is hold time. So what's meant by hold time? Hold time is the longest period of time that the cell can maintain a voltage large enough to be interpreted as logic 1. I have said dynamic RAM has got a disadvantage that its capacitive has got capacitive leakage. So capacitor charge will eventually degrades. Suppose if the capacitor stores 1 and if you are not doing the refreshing operation, eventually the charge stored in the capacitor gradually decays, and that hold time, there exists one hold time, and before if you are not doing the refreshing before the hold time, then the value stored in the cell will be lost. And if you are doing refreshment above this hold time, then that value will be retained, because hold time is the longest period of time that the cell can maintain a voltage large enough to be interpreted as logic 1. So DRAM has to employ a refresh operation periodically before the hold time of every cell. Okay, so in this lecture we have learned the dynamic RAM cell configuration. We have seen the features of dynamic RAM, and we have seen 2 configurations of dynamic RAM, that is 3 transistor configuration and 1 transistor configuration. 3 transistor configuration, we have learned how to how it's a read and write operation of 3T DRAM and the read and write operation of 1T DRAM. Hope you have all understood. If you have any doubt, please let me know. Thank you.